Hi there and welcome to another video where I work through the AQA linear past papers. This is the June 2012 calculator higher paper. It is 2 hours long, but this video hopefully I should get through it in under an hour, well under an hour. Right, let's start straight away. Andy thinks of a number, he multiplies it by 4, he subtracts 6, his answer is 7.2. What number did he think of? Let's use algebra when you're thinking of a number. So you think of this number. You multiply it by 4 first, 4x. You subtract 6 from that, and your answer, you get 7.2. Let's just solve this. Add 6 to both sides. 4x would be 7.2 plus 6, and it would be equal to 13.2. And remember, you are allowed to use a calculator on this paper, so divide both sides by 4. X is 13.2 divided by 4, and you get 3.3. So x is equal to 3.3. Now, check that works. 3.3, multiply it by 4, take away 6, and indeed you get 7.2, so you know you've got the right answer for 3 marks. Easy start to a paper. Question 2. This is about average speed. You need to know a formula from, you probably do this in science or in physics. You should know that speed is equal to distance divided by time. Some of you would have seen that formula in, or the way it's given there, in science. So for example, you know, the way I can remember this, if I don't remember this triangle, I know speed is distance over time. It's how far you've travelled in what time you've done that in. And the units often help you. Miles per hour, well, the word per means divide, so miles divided by hours is a unit of speed, and that's distance over time. So you just need to know speed is distance over time and how to rearrange this. So, Ellie drives 169 miles from Sheffield to London. She drives at an average speed of 65 miles per hour. She leaves Sheffield at 6:30 a.m. Does she arrive in London before 9 a.m? You must show your working. Well, we want to work out time here. So time, rearranging this, is distance over speed. So time is your distance divided by your speed. Now the distance was 169 and she's going at 65 miles an hour, so you would divide these two and you would get yourself 2.6 hours. Okay, so what is that exactly? Well, that's 2 hours, and 0.6 of an hour is 0.6 times 60 minutes, which is 36 minutes. So 2 hours and 36 minutes. So if she leaves Sheffield at 6:30, she gets to London, therefore, 2 hours and 36 minutes after this, so 36, it would be at 9:06 a.m. So you need to answer the question, does she arrive in London before 9 a.m? No, she does not. And you could state 6 minutes later she arrives. And that's for your 4 marks there. And it's a nice easy question really to get yourself into this topic. Okay, next question here. Is about parallel lines. Okay, so PQ and RS are parallel. These two are the parallel lines. So any Z, F angles, interior angles going on happens this way round. Okay, so I'm just going to do this. You obviously can't do this in the exam, although you could turn the paper. If I take a photo of that there, because it confuses me the way round this is, I'm used to it being the other way. What I could do is twist my paper around as such, okay, and it's the way I'm used to it. The parallel lines are the ones going across the page, if that helps me to think of it like that. Okay, write down the value of x. Now, x here is in an F position with this 147 here. And again, if it's more helpful to you like this, if you twisted your paper around, that makes it clear to you that that angle and that angle are 147. So it's 147 degrees. You can't say F angles, you have to use the word corresponding. Corresponding angles. And that's all you have to state. Okay, next one. Work out the value of y, state the reason for your answer. So going back here, if you know this one here is 147 degrees, well, y is also 147 degrees because it is vertically opposite. Okay, it's vertically opposite. Or you could say that is actually alternate to this one, because there's a sort of a, you know, there's a backward z going on here. So it's one of the two. I would probably just say, keep it simple. I would say it's 147 degrees, and I would say it's vertically opposite x. And you'll be done there. Okay, next question. Ben sees these adverts to hire the same car. Okay, one advert from Hire Deal and one advert from Best Cars. Ben wants to hire a car for 10 days. He expects to drive 600 miles. Should he choose the Hire Deal or the Best Car Deal? Show you're working. Okay, 6 marks here, so let's write everything down. Let's firstly deal with Hire Deal. Okay, and work out the cost. Now, he expects to drive 600 miles. There's no charge for mileage, okay? And the normal price is £78 each day, but now you get a third off, and the price includes VAT. Okay, so let's work out a third off. If it's £78, what's 1/3 of £78? Okay, you can use your calculator. It's simply 78 divided by 3, or a third times 78 is 26. So you're getting £26 discount. So therefore, daily charge must be 78 take away 26, which is £52. Okay, he wants it for 10 days. So total cost would be 10 multiplied by 52, which would be equal to 520. £520. Okay, and that includes VAT. Okay, now let's do Best Cars. Maybe keep it in a different colour pen. Best Cars. It's £36 a day, 15p per mile. The price excludes VAT. Okay, so firstly, let's work out the daily charge. So, charge for 10 days would be equal to 10 multiplied by 36, which would be £360. The mileage, how much would the mileage cost? Well, it would be 15p times each mile. Let's do it in pounds, so it would be 0.15 multiplied by 600, okay, for each mile. So 0.15 times 600, this would give you 90. Okay, and that would be the cost excluding VAT. So you add those together and you get £450. And VAT is 20%, so I want to add on 20%. So the VAT included would therefore be 1.2 multiplied by 450, which would be £540. Okay, so make sure you state which deal. Therefore, choose Hire Deal as £20 cheaper. Okay, it's simple as that. Write it like that, and you get yourself the mark. So nice, easy 6 marks there if you keep your wits about you. Okay, question 5. Work out the value of this when n is 13. Let's substitute in 15, okay, and then 3, and then brackets 13 plus 8. Okay, a simple substitution game. Let's do 3 times 13, which is 39, plus the 8, which is 47, times 15, and this would be 705. It's an unbelievably easy question here. 705. Get those 2 marks. There's no excuse for not. Okay, ABCD is a quadrilateral. Work out the value of x. I know the inside angles of a quadrilateral must add to 360, so I can write an equation down. I could say that this angle x plus 134 plus 118 plus x plus 16, they must add up to 360. Now, I've got 1x here and 2x, so I've got 2x's, and the numbers, if I do 134 plus 118 plus 16, I would get 268. So plus 268 is equal to 360. So subtract 268 off both sides. 2x would therefore be equal to 92. And divide both sides by 2. X would therefore be equal to 46. So x would be 46 degrees, and you're done. Easy, easy, 3 marks. Is BC parallel to AD? Give a reason for your answer. Let's look back at the picture. Is BC, is this one, parallel to AD? Now, if they were parallel, these angles would be interior angles and would add up to 180, right? Now, if you know x is 46, I could say the angle at A, okay, would be 46 plus 16, which would be equal to 62. Okay, I know the angle at B is 118. If you add those two together, you get 180. So therefore, A and B are corresponding, not corresponding, are interior angles. Therefore, AD is parallel to BC. And you could have checked it with this side as well. That one actually would have been well easier if I had done that, because that would have been 46, and 46 plus 134 are clearly 180. So that would have been a whole lot easier, although it works out this side as well. So because these add up to 180, they are interior. The only way that can be the case is if this line and this line are parallel. That's one of our rules of parallel lines. Next question. The diagram shows a triangle ABC. Work out the area of the triangle. Now we have the perpendicular height here. Perpendicular to the base is 7.3. So the area, and we're given our answer to 1dp, is half the base times the height, which is simply 1/2 multiplied by 9.5 multiplied by 7.3. There is nothing tricky or confusing about this at all. And we should get the answer 34.7 to 1dp. 34.7. Don't forget our units, centimetres squared to 1dp. That was so easy, and that actually was for 3 marks. It's very, very straightforward. Question 8. Solve the following. Okay, let's expand the brackets. 4 times 3x is 12x. 4 times -7 is -28 is equal to 20. So add 28 to both sides. 12x must therefore be equal to 48. Divide both sides by 12. X must be equal to 4. And before you move on, check you got the right answer. 3 times 4 is 12. 12 take away 7 is 5. 4 times 5 is 20. I know I got it right. Move on now. Happy in the knowledge you've got that question right. Question 9. The diagram shows a door lock. Okay, the code number, letter, number is entered by pressing a button from each row in turn. The top row, then the middle row, then the bottom row. Sarah knows that the code begins with 1. She presses 1 and then enters the rest of the code at random. Work out the probability she enters the correct code. Well, the code begins with 1. Okay, so you know that. Now, after you've chosen one, you've got a choice of A, B, or C. It's one of these. Now, if it's equally likely it could be any of these, the probability of it being A is a third, B is a third, and C is a third. Okay, and then having chosen one of these, say you chose that one, the chance of you being right in the next one, well, it's either 3 or 4. So it's either 3 or 4 in each case. Okay, and the probability of being right in the second case must be a half, clearly. Okay, so what's the probability that she enters the right code? Now, one of these is right and one of these is right. So we don't know which one it is, but let's just say it was C that was right and 3 that was right. In order to get that, it would be a third times a half. So the probability correct must be 1/3 multiplied by 1/2, which is equal to 1/6. Simple as that. Okay, so it doesn't matter which is the answer. You know to get the right one the first time is a third, and then to get the right one the second time is a half. They're independent events, so you multiply along the branches of a probability tree and you get the answer. Okay, the next question is extremely easy question on trial and improvement to find a solution to the equation. Now, you are the first guess is x is 3 for this and it's too small. So the first thing you have to do is find two consecutive integers, whole numbers, where one's too big and one's too small. So obviously let's try 4 now. So we're going to try 4, and on our calculator we're going to type 4 cubed, take away 4 times 3, and when I do that I get 52, and that's obviously too big. So there's a number in between 3 and 4 where this will be exact. It looks like it's going to be a bit closer to 4. So the next thing we need to do is find two consecutive 1 DPs, 1 decimal place numbers. So let's guess the next one. Let's guess 3.8. Okay, so we'll put in 3.8 and we get out 43.5, and that is too small. Okay, so it must be between 4.8 and 3.8. We must go for 3.9 there. When we put in 3.9, we get 47.6, and that's too big. So therefore we know it's between the one that's too small and one that's too big. These two consecutive decimals, it's between those. Now the question is now that for the third step, which one is it, 3.8 or 3.9? To get the last mark you must do this, otherwise you don't get the mark. You know 3.8 is too low, and you know 3.9 is too big. And you must try exactly halfway between these, 3.85. You must try 3.85. So if you sub in 3.85, cube it, you actually, and take away 3 times that, you get 45.5, which is too big. Okay, so this number here is too big. Therefore, between here and here, it's too big, and here, it's too small. So the answer must be exactly right, somewhere between here and here. The answer, therefore, to 1 dp is closer to 3.8 than it is to 3.9. So x is therefore 3.8 to 1 dp. Make sure you get these right because they are unbelievably easy, and you should do them in this exact way with that last check step, otherwise you're not allowed to do it. Otherwise, sorry, you're not allowed, you will not get the final mark. Next question, work out the length of AC. This length here. We've got a right angle triangle. We are given two sides. This is a simple Pythagoras question. AC squared, the hypotenuse squared, is the two other sides squared added together. Type that in your calculator. You get 1490. So AC squared is 1490. So AC must be the square root of 1490, which is 38.6 centimeters. And we are given our workings into two significant figures. So let's give our answer back as two significant figures, but tell the examiner what you've done. 39 to two significant figures. Write the decimalised version first and then show that you've rounded it. There's your nice 3 easy marks. Question 12. A gym owner wants to know the number of hours that people exercise. Write down the question he can use in his survey. Include a response section. Two important things in this. You need to ask how many hours, but you must give a time frame. You must say per week or per month, etc. Because if you just say how many hours you work out, that's a useless question. Okay, and you must have a response section with boxes to tick, and there can be no overlaps, etc. So something along the lines of how many hours per week do you exercise? Question, okay, and we could have an option here, none. Let's say up to half an hour. Between 30 mins plus an hour, and then the last more than an hour, more than 1 hour, something like that. Okay, or you could have done it in different increments as long as they don't overlap and you've given a time frame. Question 13, solve the following inequality. You can just think of that as an equal sign. Do exactly as you would do with a normal equal sign. Add 5 to both sides, so 3x must be bigger than or equal to 21. Divide both sides by 3, x is therefore bigger than or equal to 7. And your answer is as simple as that. 13b. The values -1, 0, 1, 2 and 3 satisfy one of the inequalities only. Circle the correct one. Now, here, if these numbers here were y, -1, 0, 1, 2 and 3, if they were going to be my y values, then 2y, wouldn't that be -2, 0, 2, 4 and 6? Okay, now, which one of these is correct? I know that 2y can equal -2. It's not strictly bigger than -2. It can equal -2. So this one can't be the case. Now this one here, I also know 2y can be 6. It is not strictly less than 6. It can equal 6. So it can't be that one. So the only one it can be is this one, because I know that 2y, it can be -2, 0, 2, 4 or 6, and this is the only inequality that allows you to be equal to -2 and equal to 6, as well as being 0, 2 and 4. So that is that. Okay, question 14. The table shows information about the ages of people in a club. Draw a frequency polygon to represent that data. Now, a frequency polygon, one way of remembering it is kind of like, you could kind of like think of it like a bar chart. So you could roughly do a bar chart first. We want a frequency of 4 between 20 and 30. So we want a frequency of 4 between 20 and 30. We want a frequency of 8 between 30 and 40. We want a frequency of 17 between 40 and 50. Like somewhere like there, right? And we want a frequency of 12 between 50 and 60, so we want a frequency of 12 here. Now, it's not a bar chart. What a frequency polygon does is it matches the midpoint of each interval, i.e. between here and here, it matches 25, 35, 45 and 55 with the frequency. So what it does really is it's a line between the midpoints of each of these. And it's like that, a straight line as well, not a curved line. And your frequency polygon looks like that. Now you do not have to have the bars in there at all. You could just simply plot the midpoint against these. So a frequency polygon usually, in fact, does not have the bars. It looks something like that. But just if you want to remember it, you know, it's a polygon because it's got straight lines and it's the midpoint of the interval versus the frequency. How could you remember that? Well, looking at this diagram, you knew you had frequency up the side, so you know you were plotting this up the side. If you were plotting this, well, the only thing you could do is draw a bar graph, but you knew it wasn't a bar graph because it would have called it a bar graph, not a frequency polygon. So you need to remember, in order to do that, it's the midpoint of the bars versus the frequency. Okay, question 15. The diagram shows a triangle ABC. Show that the triangle is equilateral. Now, an equilateral triangle is one where each of the sides are equal to each other. So we need to show that each side is equal to each other. Well, we are told that AB is equal to AC. So AB, this one, is equal to AC. We know that is a fact. So we can state from that that 5w must equal 3w plus 3. That is a fact we know, given we are told this here. So we could find w, right? We could take away 3w off both sides. 2w is equal to 3. We could divide both sides by 2. So w is 3 over 2, or 1.5. Now, we know that if w is 1.5, we could substitute w in here and show what each of the sides are. Well, 5 times 1.5 is 7.5 centimetres. Okay, and we should probably write 5 times 1.5 to show what we've done. Here, we would do 3 times 1.5 plus 3. Now, 3 times 1.5 is 4.5 plus 3 is 7.5 centimetres. Okay, and here, 1.5 plus 6 is obviously 7.5 centimetres, and you state all sides 7.5 centimetres, so equilateral. Okay, and the key bit to this question was actually reading that fact there. Because you were told that, you can make these expressions equal, find w, and use it to put it into the other one to check the other one's the same length as all the others. And that's done. Nice easy marks there. Question 16. Here is a pattern for the numbers 1, 8 and 17. Okay, if you take 1 and you cube it, you get 1. 8 cubed is 512. 17 cubed is 4913. And also note that 1 equals 1. 5 plus 1 plus 2, the digits of this add up to 8. And 4 plus 9 plus 1 plus 3 actually add up to 17, which is really interesting. Find a number between 25 and 30 that follows this pattern. So it's between 25 and 30, so it's either 26, 27, 28 or 29. So let's just try each one, why not? Now, 26 cubed, type that on the calculator, and you get 17576. And if you add those up, 1 plus 7 plus 5 plus 7 plus 6, well, that would be 8, 13, 20, 26. You get 26. And I mean, quite unbelievably there, I actually found that in one go there. That is the correct one. So find a number is 26. It also turns out that 27 works as well. So simple as that. Question 17. A car is advertised for £3,000. The car will be in the sale next month. Tom can afford to pay £2,500. What percentage will the price have to be reduced so that he can afford the car? Okay, so the percentage reduction, okay, must be equal to the new price, take away the old price, divided by the old price times 100. Okay, that's just a formula you need to know. And the new is 2,500, take away 3 grand, over 3 grand. It's relative, I mean, the percentage reduction must be relative to what it started at times 100. So that's negative 500 over 3,000. So to me, it looks like negative 16.7%. So the reduction must be 16.7% to 1 dp. And you're done in that regard, okay? Now, the other way you could, I mean, remember it, I'll do it in this formula here. You could think to yourself that the new price of anything is equal to percentage multiplier, okay, times the old price. Okay, now the new price is going to be 2,500 if it reduced, would be the percentage multiplier times the old price, which is 3,000, and then the percentage multiplier rearranging would be 2,500 divided by 3,000, 2,500 divided by 3,000, which would be equal to 0.833, and that indicates a reduction of 16.7%. 1 subtract that, because 1 subtract 0.833 is actually 0.167, which is a 16.7% reduction. So either way works for you. Next question. The diagram shows a semicircular shape. Find the correct expression for the perimeter of the shape. Now, let's just remember the perimeter of this shape is both the curved distance there, but also added on this straight line distance here. Okay, now the curved distance, if we know the radius is r, the curved distance of a whole circle is 2 pi r. So for half a circle, it must be pi r. So the curved is equal to pi r, and the straight line must be r plus r, which is 2r. So you add these two together, so it must be pi r plus 2r. It must be equal to that one there. The perimeter of the shape is 11.6. Calculate r, give your answer to a suitable degree of accuracy. So we know the perimeter is 11.6, and we know a formula for it is this one. So we know that pi r plus 2r must add up to 11.6, right? And we are trying to find r. Now, what you should notice here, both of these have a factor of r in them. So I could factorize r out. Okay, pi r divided by r is pi, and 2r divided by r is 2. Okay, now I could divide both sides by the bracket pi plus 2. So r must be 11.6 divided by pi plus 2. So just type that in your calculator, 11.6 divided by brackets pi plus 2, and you get yourself 2.256. And an appropriate degree of accuracy, you were given 3 SF there, so you should give your answer to 3 SF, so it would be 2.26, and state you've done it to 3 significant figures. Next question. Bags of sugar are weighed. The results are summarised in the table. All measurements are given in grams. Draw a box plot to show this information. The minimum is 210, so let's do a little bar at 210. Let's do it something like this. The maximum is 470, which should be somewhere like this. Okay, the lower quartile is 250, and the median is 310, and the upper quartile is 390. Got everything we need there. Just draw a box for the interquartile range and a little line between each of these here to the lower and upper. So let's just label this. This is the minimum, this is the maximum, min, max, and let's call this the lower quartile, the upper quartile, and this one here is the median. And you're done there for 2 marks. Okay, an extra 10 grams of sugar is added to each of the bags. Tick the correct box to show how each of the following will change. Now, if 10 is added to each of these, okay, let's just imagine every single bag at 10 grams is added. Surely, if I was to do this, let's see if I can just highlight these. Let's highlight these. Okay, if 10 was added, 10 grams, then wouldn't the whole thing move? The minimum would be up by 10, the maximum would be up by 10, the lower quartile would be up by 10, the median would be up by 10, and the upper quartile would be up by 10. Now, would the range increase or decrease? Would the difference between these, if they've both gone up by 10, then the difference between them would not go up, there would be no change. So it's no change. The median, however, would increase. I've just moved everything over by 10 grams. So of course the median would increase. And the lower quartile, well, what would happen to the lower quartile? It's moved across by 10 as well. It, of course, would increase as well. Now, just looking back, it hasn't asked us this, but would the interquartile range change? No, because the lower quartile and upper quartile have increased by 10. So if you take them away from each other, the difference is the same. But minimum, lower quartile, median, upper quartile, max, all change by 10. But range or interquartile do not change at all. Next question, complete the table of values for this. Remember what this means using BIDMAS. You take the number x, you square it first, Okay, then you double it, then you subtract 3. Do not double it first. Students often double the x first and then square it. If that was the case, the 2x would be in brackets. Remember BIDMAS here. BIDMAS says brackets first. There are no brackets. It says indices next. So you must do your x squared first, then you double it, and then you do your subtraction. Okay, so let's do that here. Let's check how this works. Negative 2 squared will be 4. 2 times 4 is 8. 8 take away 3 is 5. Correct. Negative 1 squared is 1. Times 2 is 2. 2 take away 3 is minus 1. 0 squared is 0. Times 2 is 0. Take away 3 is negative 3. And the only one we've got to fill in is this 2. 2 squared is 4. 2 times 4 is 8. 8 take away 3 is equal to 5 again. Notice it's symmetrical here as well. And the next question, okay, now let's plot this. The next question asks us to plot that for values between x is minus 2 and 2. So all we've got to do is draw a graph here. So let's, how far do we have to? We have to go up to 5 and down to minus 3 and across minus 2 to 2. So let's just pick an easy scale. That's 1, 2, 1, 2. So in fact, why don't I just do it over here like this? And we need to go down to minus 3 and up to 5, we said. So right in the middle there, let's go down 1, 2, 3. Let's go up 1, 2, 3, 4. Okay, we're not going to get 5 out of this, so we'll label it differently. We'll just, in fact, call this here 1 and 2, and this minus 1 and minus 2. And this here is 1, 2, 3, 4, 5. And this is minus 1, minus 2, minus 3. So let's just plot these against each other. Minus 2 goes with 5, so when it's minus 2, it's up to 5 there. Minus 1 goes with minus 1, so minus 1 here goes with minus 1 down here. 0 goes with minus 3, so 0 goes with minus 3, which would be here. 1 goes with minus 1, 1 goes with minus 1, and 2 goes with 5. So you can see it's a parabola. It's next squared, it goes something like that. You should draw it a bit neater than me. Make sure it goes through all the points properly, accurately. Okay, and it doesn't bend out like that. It's just a mistake how I've drawn it. It should look something like that, okay? And symmetrical as well. Okay, next question. Amy and Kate catch 3 fish. The weight of each fish, and this is the key part, to the nearest tenth of a kilogram is shown. Kate says that the total weight of her fish is more than the total weight of Amy's. Show that this could be true. Now this question is all about upper bounds and lower bounds. If you only know something is accurate to the nearest tenth, your unit of what you know the accuracy to is 0.1 kilograms. So therefore, you half this and you add on 0.05 kilograms for the upper bound, and you take away 0.05 kilograms for the lower bound. And the reason this is because, say you measure something and you measure it to be 4.3, and you know it's accurate to the nearest tenth. Therefore, anywhere between 4.35 and 4.25, this distance here being 0.1 a tenth, it could be anywhere between that, and it would have rounded to 4.3, as it were, ignoring the very ends here, which we just use for convention. So therefore, the upper bound of this number could be 4.35, the lower bound could be 4.25, okay? So let's have a go at this question here. The easiest way to get the 4 marks, I think, is to go through Amy's and go through could Kate's, okay, weigh more than Amy's? Now, for that to be true, maybe if Amy's were all the lowest they could possibly be, so Amy's lower bounds, and Kate's were the biggest they could possibly be. Maybe it could be the case. So Amy's lower bounds would be 6.75 kilograms, 4.25 kilograms, and 5.15 kilograms, which give a total, if you add those up, so 6.75 plus 4.25 plus 5.15, they give us a total of 16.15 kilograms. Now, for Kate to be bigger, maybe Kate's could have all been the upper bounds. So Kate's could have been the upper bounds, i.e. 8.25, 3.45, and 4.55. And if you add hers up then, what would her total have been? Well, 8.25 plus 3.45 plus 4.55, which would be equal to 16.25 kilograms. So in that case then, it could have actually been bigger. Therefore, Kate's could have been bigger. Okay, and that's that. It's as simple as that. Question 21. The diagram shows a triangle cut into a smaller triangle and a trapezium. Work out the area of this trapezium. Now, in the front of the formula booklet, it tells you the area of a trapezium. Okay, it tells you that if you've got a trapezium as such, and this side here is A, this is B, and this is the height between them, the area of a trapezium is equal to a half h, the distance between them, A plus B. Okay, now here's our trapezium here. Clearly this and this are the parallel lines because they're both at right angles to the base. So this is a trapezium sort of on its side, as it were. So it's kind of like that type of trapezium. So therefore the height is the distance between E and D here. So the height here would be this distance. So we need to know this distance in order to work out the area of the trapezium. Now, this question is 5 marks. It's supposed to be quite tricky, but I just want to show you it's actually not. In these type of questions that come up, I'm going to just draw it in another shape here. In fact, let me just pick a triangle like that. Now, say I picked a triangle there, and I'm going to replicate it so it fits exactly in there. Now, I am reducing that. I've reduced that triangle there, and I just want to show you that these two triangles are similar. Whenever you see a scenario like this, the triangles are similar. Why? Because obviously they share the same angle there. Okay. Now, they obviously also share the same angle here, don't they? And clearly it shares the same angle here because it fits in. So if all the angles inside two triangles are identical, this angle here and this angle here, if all the angles are the same, they must be similar. So in this case here, the triangle CDB is similar to CEA. So we could write CDB is similar to CEA. Therefore, one's an enlargement of the other. So let's work out the scale factor. If we've got that length there, that must match to that length. So the scale factor must be 12 divided by 8, which is 1.5, right? So if we wanted to work out the length between here and here of the larger triangle, we could do 11 multiplied by 1.5. And that would give us the total length. So 11 multiplied by 1.5 is 16.5. Therefore, the distance ED must be 16.5, take away 11, which is equal to 5.5. And now we can we know this distance now is 5.5, so we can work out the area of a trapezium. So the area is equal to a half, the sum of the height times the height, which is 5.5, times these two distances, 12 plus 8, which is 20. So 20 times 5.5 times 0.5, we would get ourselves 55. centimetres squared. And we're done for 5 marks. But this question was including a lot of stuff. It was including area of a trapezium and similar triangles. Do remember, if you see a scenario like this ever, then the triangles are similar. So that's what they're expecting you to use. They're expecting you to realise one's an enlargement of the other, use scale factors or something to work out missing lengths. That will help you answer the question. Okay, question 23. 2 ordinary fair die are thrown. One dice shows a number greater than 3. So if it's a fair ordinary dice, this one, the first dice either shows 4, 5 or 6, right? And the other dice shows a number less than 3. So it's either 1 or 2. Okay, strictly less than here. Put these statements in order starting with the least likely. Both dice show an even number. So, for both dice to show an even number, we'd have had to have, it would be 2/3, okay, multiplied by a half, which, because there's 2 of these, 2 out of 3, this one and this one, 2/3 multiplied by a half, and that would be equal to a third. If both dice were to show an odd number, it would have to be the 5 and the 1 here, so it would be 1/3 multiplied by 1/2, which would be 1/6, and the last one dice shows odd and the other dice shows even. So one dice to show odd, either we could have that one showing odd, which would be 1/3, and this one showing even times 1/2, or you could have this one showing odd, which would be 1/2, multiplied by this one showing even, which would be 2/3. Okay, so this would be a 6 plus 2/6, which is 3/6 or a half. Okay, so put them in order, therefore, from least likely. So least likely, therefore, must be B, which is the smallest number. Then the next smallest one would be A, and the next smallest one would be C. Okay, and it's as simple as that. Question 24, expand and simplify. Let's just move this down so we've got a bit more space. This multiplied by this, 2 times 3 is 6, x times x is x squared. 3x multiplied by negative 5y, so 3 times negative 5 is negative 15, x times y is xy. Positive y multiplied by positive 2x must be plus 2xy. And the last one, positive y multiplied by negative 5y, be negative 5y squared. And we could just do a bit of collecting up here. That would be 6x squared, negative 15xy plus 2xy, be negative 13xy, subtract 5y squared, and you'll be done for an extremely easy 3 marks there. Next question. Solve the quadratic equation, give your answer to 2 DPs with 2 decimal places. Now, because it says that, you know to use the quadratic formula. That is your hint to use the quadratic formula. It wouldn't be decimal places. You could solve that by factorising, usually with whole numbers or easy fractions. Here, decimal places means use the quadratic formula. That's given in your formula booklet. It says x is negative b plus or minus the square root of b squared over minus 4ac, all divided by 2a. So, to start with, state your a, b and c. A is 6, b is 2, and c, is very important, is negative 5. Right, and now it's just a case of substituting in. The first thing I tend to do when I'm doing these, I think it's easiest if you work out b squared minus 4ac. It makes everything easier. So let's just do b squared minus 4ac first, which would be 2 squared, subtract 4 times 6 times negative 5. It's important you get the negatives here, because 2 squared is 4. 4 times 6 times negative 5 is negative 120, but you're subtracting negative 120, so it's like adding 120, you get 124. Therefore, when substituting in, x is therefore negative b, which would be negative 2, plus the square root of 124 over 2a, which would be 12, or x is -2. Subtract the square root of 124 over 12. And then it's just simply a case of typing those into your calculator. So you get yourself, for this one here, you get 0.76 to 2 dp. This one here, you get yourself x is -1.09. And there are your answers to one decimal place, and you're done. Okay, next, Jack is making spheres out of clay. A box contains 25 packs. Each pack is a cuboid measuring as follows. So draw a picture if it helps you. Draw a picture. So this here is one pack, right? This is one pack and it measures 10 by 10 by 4. So it doesn't matter that I've drawn it inaccurate. 10 by 10 by 4. So the volume of a pack, okay, must be 10 times 10 is the area of the front of the shape multiplied by the depth. So it would be 10 multiplied by 10 multiplied by 4, which is 400 centimeters cubed, right? Now, the total volume, we've got 25 packs, so 25 packs must therefore have volume 25 multiplied by 400 centimeters cubed, which is 10,000 centimeters cubed, right? Now, the question is, how many spheres of radius 6 can you make from a box of clay, from all this 25 packs? Well, the volume of one sphere, this is given in the front of your formula booklet, is 4/3 pi r cubed, okay, which in this case would be 4/3 pi multiplied by 6 cubed. Tap that in your calculator. And it's 288 pi. Don't round at this stage, there's no point. So how many number of spheres must therefore be the total volume of clay you've got, 10,000, divided by 288 pi. And you get yourself 11.05. Well, how many whole spheres is that? It's 11 spheres. And you're done for a nice, easy 6 marks there. All of these formulas, this one here, and the volume of a sphere, which is 4/3 pi r cubed, are given in the formula booklet. So it's just a case of substitution and simple logic. Okay, next question. A pack of clay has a mass of 500 grams. Work out the density of clay. Now, this again is a formula you should know from science. You should know that the density of a subject, the density of an object is its mass divided by its volume. And it's like a speed distance time graph. Speed distance time triangle. Density is mass over volume. It's how much of something there is in a given volume. Okay? Now, a pack of clay, one pack of clay, not the 25 packs of clay, has a mass of 500 grams. What's its density? Density is mass over volume. The mass is 500 grams, so it's 500 over a volume of 10 by 10 by 4, which is 400 centimeters cubed. Keep the units in, so it's 500 grams over that. So you do 500 divided by 400, and you get yourself 1.25, and the unit is grams per centimeter cubed. Now, if you could not remember this formula or you've not seen it before, the units here gave the game away. Grams per centimeter cubed. This answer here was supposed to be density, right? And it told you that the units were grams per means divide, centimeters cubed. Now, grams is mass, isn't it? And centimeters cubed is volume. So you get your formula density is mass over volume by looking at the units. Or, from now on, you remember this set of formulas here. Okay, 27. Prove that the following is equal to the following. Basically, what we're asked to do here is we should take the left-hand side, play around with it, and show it's equal to the right-hand side. So start with the left-hand side. Let's just write down the left-hand side. 3n subtract 1. Let's write everything in brackets. It makes everything a whole lot easier. Okay, we're going to start with the left-hand side. Now, they are algebraic fractions. You cannot add fractions or take them away until the bottom numbers are the same. So, I'm going to write this one out again. And I'm going to write this one out again. Okay, now, what do n and n subtract 2 go into? What's the lowest common multiple? Well, it's their product, n multiplied by n minus 2. So this one needs to be multiplied by n minus 2, right? And this one already has an n minus 2, needs to be multiplied by n. And then they would be over a common denominator, and you could combine them. Now, let's just times this bracket out here first. Remember that we've got a minus. 3n multiplied by n is 3n squared. 3n multiplied by negative 2 is negative 6n. Minus 1 times n is minus n. Minus 1 times minus 2 is plus 2. And let's do this one over here. N multiplied by that is 3n squared. N multiplied by that is n, all over n minus 2. Okay, I have not combined these yet. Now, at this stage, I can combine them. But remember, this takeaway means take away everything in this second bracket here. So, we have, now we combine them. 3n squared, take away 3n squared, is no n squared. Okay, so the 3n squareds will cancel. Negative 6n, subtract an n is negative 7n. Subtract another n is negative 8n. And 2, subtract nothing is simply 2. And it would all be over this here, which is exactly the same as the top, apart from I've just switched the order around, and it's equal to the right hand side, and you're done. So the key was with this question in summary, start with the left hand side, bracket everything up to remind yourself that we're going to do timesing in a second. Pick the lowest common denominator, to be the product of the two. This one needs to therefore be times on top and bottom by n minus 2. This one needs to be times by n. Then do that timesing, but keep everything in brackets in each side of the fraction, and then do your subtraction on the top, and you will get the right hand side for 4 marks. Okay, and question 28. A bag contains blue, red and white counters, 4 blue, 4 red, 4 white. 2 counters are chosen at random without replacement. What is the probability that the counters are different colours? When you think of this in just like trying to work it out in your head, it's all of a sudden a nightmare. If you actually draw out a tree diagram, it's the easiest thing in the world. So let's just do a tree diagram. A bag contains 4 blue, 4 red, 4 white. So if you pick out first, clearly you either get blue, red or white. Okay? Now, the probability of blue is 4 out of 4 plus 4 plus 4, which is 12. Don't simplify these now, because if you try and simplify, all of a sudden it makes the next branch harder. Just leave it like this. The probability of red is 4 out of 12. The probability of a white is 4 out of 12. Okay, now, having taken, I'm just going to actually, might actually do this over here. It might make things a tiny bit easier. Having taken a blue, okay, now I'll do this in the green pen. I could get blue, red, or white again, couldn't I? And I could get blue, red, or white, or I could get blue, red, or white. Okay? Now, having taken a blue, what's the probability I get another blue? I've taken a blue, what's the probability I get another blue? Well, there's only 3 left out of 11 balls left now in total, because it's without replacement. Okay, what's the probability this was supposed to be red? I get a red, there are still 4 out of 11, and this one here would be 4 out of 11. Now, in the next scenario, I've taken a red, so what's the probability I get a blue? 4 of 11. Probability of another red, 3 of 11. Of a white, 4 of 11. And this one here would be 4 of 11, 4 of 11, and another white would be 3 of 11. Now the question is, there's the diagram that's going to explain everything for us simply. What's the probability that the counters are all different colours? The two counters are different. So either it's blue and red, so it's blue and red, or blue and white, or red and blue, or red and white, or white and blue, or white or red. Okay, so there are, we can do a bit of timesing here to work these out, and add all of those up, and that would be fine. So that one way of doing this would be to say it would be that times that, and that times that, and that times that, and that times that, etc. But a clever way, well, let's just do that just to show how it works. Blue and red would be 4 twelfths times 4 elevenths, which would be 16 over 132. And we'd add blue and white, which would be 16 over 132. And you can see actually that all of these are going to be 16 out of 132. So it's going to be, in fact, it's going to simply be 16 out of 132 multiplied by 1, 2, 3, 4, 5, 6. And you multiply that by 6. And you get yourself 8 over 11. Okay? Or another way of doing it, just do it in a different coloured pen. The probability that all colours are different is 1 minus the probability that all colours are the same. And the probability that they're the same is 4 twelfths times 3 elevenths, 4 twelfths times 3 elevenths, 4 twelfths times 3 elevenths. So 4 twelfths times 3 elevenths, and that times 3, it would be 3 elevenths, so it would be 1 minus 3 elevenths, which again would be 8 elevenths. And that's another way of getting this there. And that is the entire past paper solutions for the June 2012 Calculator 2-hour paper. Thank you for watching.